Hello everyone, this is the first in a series of videos I'm going to do for the next topic in the third year Nat5 course, which is all to do with trigonometry, but in particular for non-right angled triangles. Okay, so studying trigonometry is something you've already done at the very start of the third year course, at the end of your S2 course. But that was focusing on right angle triangles only, and you'll remember doing SOHCAHTOA and everything like that. This is trigonometry methods for non-right angle triangles. So it's quite a big unit, it's quite a large part of the National 5 course. These are all the learning outcomes for it, starting with at the top, looking at how we find the area of a triangle using trigonometry, and then how we use something called the sine rule, and then the cosine rule for finding sides and angles of a triangle. And then at the bottom, the last two bullet points is about problem solving and taking a wee look at triangles involving bearings and things like that. So it's quite a big unit. It'll probably take at least a couple of weeks to get through. All right, so today's lesson is going to be on the first bullet point here at the top. I can calculate the area of a triangle given two sides and the angle in between them. So before we begin this topic, what we really need to do is take a wee look at how to label up the angles and sides of a non-right angled triangle, right? There's a very simple and effective system for letting us do that, okay? So let's have a wee look here, right? Consider for a moment triangle A, B, and C, right? That's the capital letters A, B, and C. Now, the simple system is, if we're referring to an angle, we use the capital letter, right? So if I was referring, for instance, to angle B, then I'm talking about that angle there, and I would use the capital letter B to work with it, okay? If I was wanting to refer to its side, right, then the length of the side opposite the angle is using the same letter, but with a lowercase. So if there's angle B, right, then opposite it is side B. And we use lowercase b so that we don't get confused between angle B. Okay, so up here we've got angle B, opposite it side B in lowercase. Now you can see the same sort of thing for angle A, and opposite it is side A. Right, and same again for angle C, opposite that is side C. Right, so it's nice and simple. Uppercase letters for angles, lowercase letters for sides, and the side opposite an angle has the same letter. Right. Let's have a look at this question here. Now, what you could do, right, is pause the video and see if you can have a wee think about this question. How we work out the area of this triangle, just given the information that's there. Now, that's quite tough to do, but you might want to pause the video and give it some thought. What I'm going to start off with is a proof, right? So what this is aiming at is a proof for how we can use trigonometry to calculate the area of a triangle. I'll go through the proof. It's not something you will have to do again, but it's useful to see where this formula is coming from. So if you want, pause the video, give it a bit of thought. If not, just keep watching. I'm going to go through the proof just now. All right. So calculating the area of a triangle using trigonometry, well, it really starts off with what you already know, right? You should already know the formula for calculating the area of a triangle. half base height, right? So remember, the height refers to the height of a triangle that's at right angles to the base. Okay, so if we knew the length of the height and if we knew the length of the base of the triangle, we could just do a half times the base times the height. But you don't know the height of this triangle. Okay, we didn't give you it to start with. So what we need is a substitution or replacement for h. Right? We need something else to be there so that we can perform the calculation. Because if you don't know the height, you can't do a half times the base times the height. So it's useful to think of this as a right angle triangle. So if I draw out what we have here, let's see. We've got the height, the right angle, A, and the angle at C. Right? Now, using SOHCAHTOA, remember that's trigonometry for right angle triangles, using SOHCAHTOA, we can say, right, this from this angle at C, H is the opposite, and side A is the hypotenuse. So that would be the sine formula. Sine of the angle is the opposite divided by the hypotenuse. So let's sub in what we have here. Sine C equals, the opposite side is H, over the hypotenuse side, which is A. Now, a little bit of algebra here, a little bit of changing the subject of a formula, that's going to help us get a replacement for H, because if I wanted to calculate H, then I would just multiply A and sine C together. So the height will be equal to A times sine C. So that there is my replacement for H. So what does that get us? Well, that gets us the area is equal to a half times the base times, now instead of H, we're going to put A times sine C. And then to tidy it all up, we'll get it written nice and neatly, no times signs, we'll get the letters in the right order, so we'll have a half AB sine C. And that is the formula for calculating the area of a triangle if you know two sides and the angle that sits in between them. Now, the really good news is that that formula is on the formula sheet for Nat5. So you don't have to memorize that formula, although it's really good if you do. But if you forget it, then it's on the formula sheet for you. Okay? So area equals a half AB sine C. Two sides and the angle that sits in between them gets you the area. Let's have a look at some examples. Oh, in fact, before we look at an example, one last thing to say. Remember what I said at the start of this proof. This is not a proof that you need to memorize. If you've struggled with the proof, because I know some folk do, if you've struggled with it, then the thing you really just need to take away is what the formula is and a little bit of an appreciation for where it's come from, but it's not a proof that you will need to redo as part of your exam. So let's now have a wee look at an example. So calculate the area of this triangle that's shown, given your answer to 1 decimal place. Right, so have we got the required information? Right, it's always a useful question to ask yourself at the start of all of this, right? It's also good if the triangle's been labelled up A, B and C, let's label up the sides as well. So What is side A? Well, side A is 14. What's side B? Well, that's going to be 12. So that's opposite there. That's opposite there. And that's side C there. Okay. So we have all the information that's required. We've also got, I want you to notice the pattern here. We've got 12 centimetres and 14 centimetres, and 55 degrees is the angle that sits in between those two sides. So we can use the area of the triangle formula. Area equals a half AB sine C. Right? So the area equals a half times side A times side B times sine 55 degrees. Right? And if you just put it into your calculator exactly like that, you will get a correct answer of 68.8 centimetres squared. Right? And that is to one decimal place. Okay? So it's not a difficult formula to work with. Right? The hardest part about it really is just making sure you've got the correct information. Alright? One more example. Let's have a look at this one. We're going to calculate the area of the triangle shown, giving your answer to 3 significant figures this time, so a little bit of revision of significant figures. Now, this triangle hasn't been labelled, right? And one of the things quite early on in the trigonometry unit that I find in experience is students get a bit of a muddle about labelling sides, and they must have A and B and what's C and all that kind of thing because you're trying to match things up with a formula. But remember that um, at its core, this formula just needs two sides and the angle that sits in between them, right? So if you've got that, then you can use this formula without having to fuss over what's side A, what's side B, and what is sine of C. So you can just go straight to the formula and say, right, well, this area is a half times the two sides, so times 60 times 50 times the sine of the angle times sine 55. All right. So what does that give us? That gives us 1228.72 dot dot dot. And then I'm going to give this now to three significant figures. So three significant figures. How do we do that again? A little bit of a recap on significant figures. Identify the third significant figure. So remember, the digit 1 here is the most significant, so that's the first significant figure. Then we work in from the left, so this is the second, and then this will be the third significant figure. So we round, that is a tens digit, so we round to the nearest 10, so 1, 2, 3, 0 centimetres squared to 3 sig figs. Okay, so that's how we calculate the area of a triangle, folks, right? What we can do is you've got the textbook exercise in your book, exercise 18.1, question 1, 3, 5, 6, 7, and 10. What we'll do next is I'll probably do another video that gets you to use the area of a triangle formula in a different way, so that instead of working out the area, what we'll do is give you the area and you have to work out the angle. So we'll kind of working backwards. That'll be the next video we'll do, and then from there we'll move on to do to take a look at the sine rule. So give those questions a go. Remember, take photographs, send your teacher your work, and see how we get on from there. Okay. Thank you very much.